So let us look at what is integration by parts. Is when most of the rules fails by direct integrals. So we have to resort to the last stage, which is basically integration by parts. So the formula says this: integral of u dv is equal to uv. So integral of u dv is equal to uv minus integral of v du. All right, so this is my formula. Now we're going to apply this formula in the different now. How do you look at the forms? What are the forms of integration by parts when we have mixed forms, right? What are the forms? You will have exponential, right? You'll have exponential functions mixed up with polynomial functions, right? And you'll get mixed up with trigonometric functions, right? Or sometimes you'll have power functions. Like trig power functions. Now, look at the first form. The first form is polynomial mixed up with trig. So obviously, it's x times cos 2x. We want to integrate x times cos 2x. So we need to choose a u in such a way. Now, how do we choose a u? We choose a u in such a way that it is differentiable. So x is differentiable. If you try to differentiate cos, it doesn't reduce anything. It just goes in circles, cos, sine, cos, right? And so on. So we say let u equal to, remember this is written in the form integral of u dv. So we say let u equals to x and the balance is dv. If this is u part, then the balance, everything else is dv. Right, let u equal to cos, let u equal to x and dv equals to cos 2x dx. Okay, now what do? We differentiate and we integrate this because we want to solve for v here. So v is equal to, what's the integral of cos 2x dx? Sine, because the derivative of sine, yeah, so sine 2x over 2. No plus c here, okay? You only put a plus c at the end. Let u equal to x, so what is du equal to dx, right? So what was the formula? Integral of u dv. Let me call this the integral, right? So the integral is now equal to uv minus integral of v du. What is uv? uv is x, see how I'm multiplying? That times that minus the product of those two. So uv is x times v. So uv is x times half, so half x sine 2x. I just wrote it in a better way. X sine 2x over 2 is half x sine 2x minus integral of v du. What is v? V is this entire thing, which is half sine 2x. And what is du? Du is dx. See, I'm using this formula v. U times v is, where's the u? X. Okay, I should have written it like this for you because I'm doing it for the first time. So x sine 2x over 2. There's your u. There's a u here. There's a v here, right? Minus v. This entire thing is v, right? And what is du? Du is dx. Okay? And now it's easy to integrate this because this is just half x sine 2x minus half. The integral of sine 2x is negative cos 2x divided by 2 plus a c. Now you add a c. Now we can take out, if you, okay, let's leave it like this, half x sine 2x plus quarter cos 2x plus c, plus quarter cos 2x plus c. Yeah. Right. This is a nice method. Now, very important is when you have polynomial. Okay. So what we do is we differentiate one and we integrate the side. We differentiate the u and we integrate. So this here can also be summarized. There's a nice method, shortcut method for this. We call it the DI method, differentiate integrate method, right? This usually works with when you have integral of polynomial versus other functions, dx, okay? It can be any other function like exponential, but you must have a polynomial, okay? Then it works nicely. So we wanted to find the integral of x cos 2x dx. So we say differentiate, integrate, okay? And see how easily the answer is solved. What are we going to differentiate? What we're going to differentiate is the u, okay? We chose a u, so there's a u here. U was x. If you differentiate x, you get 1. And if you differentiate 1, you get 0. A repeated differentiation, okay? Start with x, u is equal to x. Differentiate x, you get 1. Differentiate 1, you get 0. Now, what are we integrating? Integrating cos 2x, okay? If you integrate cos 2x, we get sine 2x over 2. And if you integrate this again, you're going to get divided by 2 again. So it's going to be negative cos 2x over 4, right? And now what we do is we multiply and we take opposite sign. We say plus, minus, right? So there's nothing else here. So plus, minus, plus. So you alternate the sign, plus, minus. If there was a third one, then you say plus, minus, plus. So what's our total rule here? You're just going to show this method. And your answer is x times sine 2x over 2. You're going to multiply those two with a plus. So half x sine 2x. And remember, minus and minus makes a plus. And you're multiplying by 1. So plus quarter cos 2x plus c. Does that make sense? You understood that? We got the same answer there. Now this works best for formulas, right? Are we good? It works best with if I have a polynomial function multiplied by any other function. So there, I have a polynomial function here as well. Okay, let me change this to x squared, okay? I change the question to x squared because I want to apply this rule over here. Okay, Farooq? Right, so this rule is the DI method, differentiate, integrate method, differentiate, integrate method, right? Why are we applying integration by parts? Because it's a mixture, it's a multiplication of two different types of functions, right? I can't really integrate that. I can integrate individually, but I can't integrate the product of two different types of function. So I'm going to start off with the x squared. Then the derivative of x squared is 2x. Derivative of 2x is 2. Derivative of 2 is 0. We start with the integral of e to the power x, e to the power 2x. Integral of e to the power 2x is e to the power 2x over 2, right? Then integral of e to the power 2x again is e to the power 2x divided by 2, divided by 2, divided by 4. And then integrate this, e to the power 2x over 4 times 2, which is 8. And what do? We multiply. Multiply. No, 0 times that. So now you've got 3 different ones. So you got plus, minus, plus. Now, remember, we're integrating from 1 to 2. So you're going to say x squared times e to the power 2x over 2 is x squared e to the power 2x over 2 minus, remember 2x, there's a minus here, 2x times negative times e to the power 2x over 4. So minus 2x e to the power 2x over 4. All right, e to the power 2x over 4. Then we have plus 2 e to the power 2x over 8, and is integrating from 1 to 2. Right, let me not integrate from 1 to 2, let me make it from 0 to 1, okay? Change the integral from 0 to make it easier. I don't want to go, because you know what to do there. Substitute upper boundary minus lower boundary and stuff. All right, so integrate from 0 to 1. So now let's see, we're going to integrate from 0 to 1. But remember, you can also simplify the function on the inside by taking out e to the power 2x. So if I take out e to the power 2x, I'm left with x squared over 2, so half x squared. 2x over 4 is x over 2, so half x, and plus quarter. Okay, because 2 divided by 8, I'm taking out e to the power 2x as a common factor. So from 0 to 1, right? And now we substitute 1 in the upper boundary, we get e squared. We're substituting 1 here, so half minus half is 0, so quarter. Subtract lower boundary, substitute e to the power 0 is 1. Substitute 0 here, 0 there, just get quarter, right? So my final answer is I can take out quarter as a common factor. Quarter into e squared minus 1. Or you can say the answer is e squared over 4, e squared minus 1 over 4. Right? Same thing. Okay. We can double check the answer with the calculator. We can say integral alpha x squared alpha e, e is shift e to the power 2 alpha x, and we're integrating from where? 0 to 1. We're getting 1.597, 1.597. And let's check if e squared minus 1 over 4 is 1.597. E squared minus 1, no, minus 1 at the bottom. Typing it incorrectly. Minus 1, and then divided by 4. Yes, 1.597. Okay, so we are on the right track. Moving on to the next question. How do we go and find the integral of ln x? Right? How do you go and find the integral of ln x? Remember, the integral of ln x is not 1 over x. The integral of 1 over x, yes. Integral of 1 over x dx is ln x. Right? Plus c. But now I want the integral of ln x. Right? What is it? So we need to apply integration by parts because we want a bigger function. So we're going to say this is equal to integral of u dv, which is uv minus integral of v du. This is my formula. So what is my u and what's my dv? U is ln x, something that I can differentiate, right? So say let u equal to ln x. What's dv? dv is the balance, which is dx. Right? I can differentiate this. So du is equal to 1 over derivative of ln x is 1 over x dx, and integral of dv. So just v is equal to x, because if I differentiate v equals x, I get dv equals dx. All right. Now I can apply this into the formula. I can say the integral is now equal to uv. What is uv? X ln x minus integral of v du. V is x. What is du? 1 over x dx. So we can see the x and the x cancels out. It's x ln x minus, remember the x and the x cancel out. See what we have done. U times v is x ln x, u times v minus v. What was v? X. What is du? Look at this formula. There's a formula I'm substituting into. uv minus integral of v du, which is 1 dx. Integral of 1 is x plus c. So what's the integral of ln x? X ln x minus x plus c. Farooq, you understand?
Yes.
Right. See how this formula is. It's easy to learn the formula. See, UdV, alphabetical order, UdV is equal to UV minus, switch this here on from the original, VDU. It's easy to learn the formula, right? So that's my answer for that problem. Let's look at the next one. Okay, the next one is easy because, hey, wait a minute. I've done an example like this, x squared e to the power 2x. Yeah, I kind of like changed it here. All right, so x squared e to the power, let's make it e to the power x rather, right? Make it easier. What's x squared e to the power x? So we're going to use the DI method. All right, so I'm going to start with x squared. Derivative of x squared is 2x. Derivative of 2x is 2. Derivative of 2 is 0. You must stop at 0, okay? Obviously, because after that, it's just going to repeat itself. Integral, we're integrating e to the power x. What's the integral of e to the power x? Again, e to the power x. Integral of e to the power x is e to the power x, e to the power x. Right, so we stop there because no need to go for the next one. To multiply those two, multiply those two, multiply those two, add, minus, and add, right? So we have x squared e to the power x minus 2x e to the power x plus 2e to the power x plus c. Don't forget the plus c. You can take out e to the power x as a common factor, and you got x squared minus 2x plus 2 plus cc. That's my final answer. Okay. Now, obviously, if you're finding exact integrals, definite integrals, then you're going to drop the plus c and substitute your boundaries. Quite simple, all right? Let's look at the next one, x arctan x, right? What's the integral of x arctan x? Now you need to choose your u and your dv wisely, right? Right, so what we're going to do is this is equals to uv. This is basically equals to integral of u dv. This formula is u dv. What you're going to make equal to u and what you're going to make equal to dv. That's the thing. If you're going to make dv equals to arctan x dx, you're going to end up integrating arctan x dx. Bigger problem you have, okay? The formula is u dv equals uv minus integral of v du. See, if you're going to start off with this, let u equal to x and dv equal to arc tan x dx. Now you're coming back to the original problem because we don't even know what's the integral of arc tan x, right? So we can't use this. You can't use this. You must use the other u substitution then, right? So let u equal to, we're choosing this one here. We drop this. We can't use this one now. So this one incorrect. So choose the next one. Let u equal to arctan x. And then dv is equal to x dx. Right, so what's the derivative of u? Derivative of arctan x is 1 over 1 plus x squared dx, right? Derivative of tan inverse, because the integral of this is arctan. And v is equal to x squared over 2. Now use the formula. Let's call this the integral. So the integral now becomes uv minus v du. What is uv? U times v is arctan x. Let me not write arctan. Let me write tan inverse. Right? It's the same thing. V is x squared over 2 minus integral of v du. What is v? V is x squared over 2 times du. V du. Du is, you know how we multiply. You're doing like this. Multiply and multiply these two and subtract. So multiply these two and then multiply those two and subtract. So u times v minus v times u. Du is 1 over 1 plus x squared dx, okay? Now I have a problem with this one. because this here looks like a partial fraction, isn't? So we're going to say this is in negative half. Let me call this integral I2, okay? Negative half integral of x squared over 1 plus x squared dx. But what we can do is we can add 1 and we can minus 1, okay? So we got negative half integral of x squared plus 1 over 1 plus x squared, same thing, 1. And this one will be minus 1 over 1 plus x squared dx. All right, so that's negative half. Integral of 1 dx is just x. Integral of this, the integral of this is the arctan again. Okay, so now I have a total integral. Don't forget to add a plus c. And so my total integral total is now equal to tan inverse x times x squared over 2 minus, remember the minus half. This was a minus half, right? Minus half, yeah. So minus half x, minus half times minus half is plus half. All right, and that's my final answer. We can take out tan inverse x as a common factor if you want. Take out half tan inverse x as a common factor. Half tan x squared minus, only from those two, all right? X squared plus 1. Half tan inverse x, half tan inverse x, x squared plus 1, because I'm taking that and divide by this, yeah. Minus half x plus c. You don't have to do this, right? You can stop there. That's good enough. We're just simplifying to check. Now we have a similar thing here, but we want to find tan inverse x. Now it's nice to know, hey, wait a minute, if I'm finding tan inverse x, what am I actually finding from 0 to 1? I'm actually finding the area under the graph. And you know what the tan inverse graph looks like? The tan inverse graph looks like this. The asymptotes are at minus pi by 2 and pi by 2. This is where the asymptotes are at. There's pi by 2. And the next asymptote is at minus pi by 2, right? This is the x-axis and the y-axis. That's negative pi by 2. And you know the tan inverse graph looks like this. If you go to inverse function, you'll find it there. Now, you are trying to find the area between 0 and 1. So if you're trying to find the area between 0 and 1, you're finding the area of this. So obviously, you need to get some form of an answer. Right. So as we said before, you need to make u equal to tan inverse x. Let u equal to tan inverse x. And dv, remember your formula, integral of u dv is equal to uv minus integral of v du. Right, minus the integral of v du, uv minus the integral of v du. Right, so what is dv equals to dx? So v is equal to x. And the derivative of tan inverse is 1 over 1 plus x squared dx. So now we have the integral, which is equals to, what's uv? uv is u times v. Remember, we're multiplying and then we're subtracting like this. U times v is x tan inverse x. X tan inverse x minus v du, integral of x over 1 plus x squared dx, v du, okay? Now, in this case, you can't go, obviously the first part we can work out a value, right? Because remember that is from 0 to 1 still, 0 to 1. So we can evaluate this part, right? But now my problem is to evaluate this. What is that, right? This is in the form of u substitution because the derivative, you can make u equal to 1 plus x squared. The derivative appears on the numerator. So let u equal to 1 plus x squared. So du is equal to 2x dx, right? So this integral I2 now becomes, we need to change the boundaries here, 0 to 1. So remember, what is x dx? X dx is du over 2, and that's 1 over u, right? 1 plus x squared is u, so I've filled that in. X dx is du over 2, so both the formulas are substituted in here. Now we want to know if the value of x is 0, what's the value of u? 1. If the value of x is 1, then the value of u is 2, right? So now I can evaluate this integral. So this is now half ln absolute value u, right, from 1 to 2. So what's the answer? Half. Substitute 2 here, ln of 2 is ln 2, and substitute 1 here, ln of 1 is 0. So half ln 0, right? Sorry, half ln 1, which is 0. So I have an answer which is half ln 2 here. What's the value of this? I didn't evaluate this as yet. If I substitute 1 inside here, 1 times tan inverse, what is tan inverse 1? Tan inverse 1 is basically pi by 4, right? So that is pi by 4, and tan of 0 is just 0. So pi by 4, and what it was the value of this? Half ln 2, so minus half ln 2. Now I want to see what the decimal value of this is, and I want to put it into the calculator to double check, right? So I'm trying to find the integral from 0 to 1 of tan inverse x, shift tan alpha x, okay? And I've got an answer of 25.14. Oh no, this is in degrees. Be careful. We need to put our calculator in radians mode. Yeah, so I'm getting an answer of 0.4388. 0.4388. Now I want to check if it's the same answer using this, what I've calculated. Shift pi over 4 minus 0.5 ln 2, half ln 2. Yeah, getting the same answer, right? So I hope you guys are understanding. We good, Farooq?
Yeah, teacher, I have one question. In the
Yes.
second, in the I2, when
Yeah,
we use the U substitution method,
correct.
but
Yes.
what will be if we'll replace the x to the right side like this? It will be like 1 over 1 plus x squared times x, and it will be like 10
No,
inverse times
no,
x.
no,
It will
no,
not
no,
possible?
no. It will not. It will not. Because you see, the integral, you have to look at the integral. The integral is in the form derivative. The integral is in this form. The derivative of a function appears in the integral. So you have something like this, f prime x, and you have something like this. It's like in this form. So you have to go and use u substitution. That will end up being ln form, ln f of x. Let's see. Okay.
Okay,
All right. So
okay,
that's a form. You see that because the derivative appears in the integral, the derivative of the function appears in the integral, it will always be u substitution. Okay.
okay.
I can give you another example of u substitution, but using e, right? So if I ask you what's the integral of this, uh, what's the integral of, I can put e to the power x cubed plus 3x plus 2, right? And over here I can put 3x squared plus 3, for example. So what's the integral of, so you see the derivative That's my u. So the derivative appears in my integral, right? So my answer is just e to the power x cubed plus 3x plus 2 plus c. Differentiate this and see if you get the inside. Yes, we do. We leave the power the same and we differentiate the top. 3x squared plus 3x. There, it works. 3x squared plus 3. Okay. So this is, it has to be u substitution because the derivative appears in my integral.
Okay.
Great. Good question. Let's move on to the next one. What happens in this case? How can I solve something like this? Okay. To solve something like this, see the way it is written. If x cubed sine 2x is equal to all of this, or minus 3 over 2 x squared cos 2x, then what does f of x equals? So obviously what they are asking you for here is some kind of a function, but this is 3 over 2. See the second part, the way it's written. So obviously they are trying to use integration by parts here. So we're going to redo this original problem and then compare and see what the function is. They don't want you to solve the entire thing, all right? So we know this is integral of u dv, which is uv minus integral of v du. And so we need to choose our u in such a way. So we have to choose the u as x cubed. Okay, we have to choose our u as x cubed and dv as, I have to choose our dv as sine 2x dx. If you differentiate u, you get 3x squared dx, right? And if you integrate dv, you get negative cos 2x over 2, 2x over 2, yeah. Because the derivative of negative cos is sine, yeah. So now, remember, to find the integral, we're going to do that. Multiply and subtract. Multiply those two and subtract the product of these two. So let's call this the integral. So the integral now becomes uv. What is uv? X cubed times negative cos 2x over 2, subtract the product of these two. So the product of these two is v du. V is negative cos 2x over 2 times du is 3x squared dx. So now you can see where this is coming from. So what we have is negative half x cubed cos 2x plus 3 over 2 x squared cos 2x dx. Okay, so now you can see you got 3 over 2 x squared cos 2x dx. Supposed to be negative 3 over 2 here. One second, I just want to check this out. What's the integral of sine? Integral of sine x dx is negative cos x. That's correct, right? Because if I differentiate cos, I get negative sine. Yeah, so this one here, there's something wrong here. Should have been negative, negative. In order to make this negative, yeah, this whole thing is negative, that is positive. If I make this negative, 3 over 2 v du. Yeah, no, I think there's a problem here. It should have been plus, okay? Not a minus, it should have been a plus. Yeah. Uh-huh. All right, so we can see clearly that f of x is this function over here. What is f of x? This entire function here. So the answer is, so f of x is basically equals to negative half x cubed cos 2x. Now, did we evaluate this integral? No, we did not. If you want to evaluate the integral, you can use the DI method. Differentiate x cubed, right? And keep on integrating this, okay? we should actually do it integral of. So this is your additional question. What if I try to integrate the whole thing? Please do not use integration by parts formula. Then you have to end up using the parts formula 3 times. Integral of x cubed sine 2x dx. That's what we had, right? Yeah. So if you want to integrate this, just use the DI method. Differentiate, integrate, okay? So we're going to go here. That's x cubed. That's x cubed. Differentiate x cubed, you get 3x squared. Differentiate 3x squared, you get 6x. Differentiate 6x, you get 6, and then 0. Repeated differentiation until you come to 0. Now, what are we integrating? Sine 2x. So if you integrate sine 2x, you get negative cos 2x over 2. If you integrate that, you get negative sine 2x over 4. What is the integral of cos? Sine, derivative of sine is cos, yes. Integral of negative sine is cos 2x over 8. And then the last one, integral of cos, derivative of is sine 2x over 16. So we're going to do this. That times that, that times that, that times that, and that times that. So plus, minus, plus, minus. Right. So my final answer is x cubed. So negative half x cubed cos 2x. Negative negative makes a positive. Positive 3 over 4 x squared. Sine 2x. This is positive, negative, positive here now. That's 6 over 8 is 3/4 x. 3/4 x cos 2x. And then the last one is minus 6 over 16 is 3/8 sine 2x. And then plus c. Right. So we're going to avoid doing integration by parts 3 times or 4 times. Right. Especially because we have a polynomial function. So nice question there. Let's continue. Question 8. Define or tabulated data. Right. So the table below gives values of f prime, g prime for selected values of x. Now I want you to focus on this 0 to 2. If 0 to 2 of f of x, g prime x dx is equal to 10, then what is 0 to 2 of f prime x g of x dx? Now, this is not making sense, so we're going to rewrite it, okay? Integral 0 to 2. Okay, 0 to 2 of f times g prime dx. So think of this as u dv. Integral of u dv is equal to uv minus integral of v du. So let's look at this. Let u equal to f of x. So what is du? F prime x dx. That's u. What is your dv? Your dv is something that you can integrate. G prime x. So dv is equal to g prime dx. So what's v equal to? What's the integral of g prime? G. Okay. G means g of x, all right? So we're going to cross multiply like this and solve. So this part of the integral, call this the integral. So the integral now becomes uv, all right? uv minus, what is uv? U times v is basically, what is u? U is f of x V is g of x evaluated at 0 and 2. Subtract integral of v du. What is v du? V is g of x and du is f prime x dx. Okay. And remember, don't forget the boundaries 0 to 2 here as well. All right. And what is this entire answer equal to? They told us the answer is equal to 10. Okay. So we're going to make that equal to 10. So now, what are you substituting? You're substituting the upper boundary in here. What is f of 2? F of 2 is 4. This is f of 2, right? You're going to substitute 2 in x, so you get f of 2. What is f of 2? There's the x values. F of 2 is 4. And what's g of 2? Negative 2. So 4 times negative 2. Subtract. What is f of 0? F of 0 is 1, and g of 0 is 2. So subtract 1 times 2. Yeah, so what is this? This value here is negative 8, negative 2. Right, so that's negative 10. That goes over, it becomes 20. 20 multiplied both sides by negative, it becomes negative 20. So this implies the integral from 0 to 2 of f prime x, g of x, dx. It is 20, all right? So I'm going to multiply both sides by negative. We'll get negative 20. So what's the answer for this? What's the answer for this? Negative 20. So nice question. Right, let's look at the next question here. Find, question number 9, find integral e to the power x sine x dx. How are we going to solve this? We have a mixture of exponential function and a sine function, okay? So we have exponential and trig mixture. So we are going to say let u equal to e to the power x, dv equals to sine x dx. Or let's make the other way around. It's possible, right? So this is integral of u dv minus is equal to uv minus integral of v du. If I differentiate e to the power x, you get e to the power x, all right? I should have differentiated sine and then cos, then sine, because if I keep on integrating this, it doesn't matter, right? So let's just say u equals e to the power x dx, and v is negative cos x, right? That's just negative cos x, yep. So uv minus v du, so the integral now becomes, what's u times v? E to the power x times negative cos x minus v du. V is negative cos x, and du is e to the power x dx. So the integral is now equals to e to the power x negative e to the power x cos x plus integral e to the power x cos x dx. Negative e to the power x cos x plus e to the power x cos x. Yeah. Now we got a problem because this part here is another integration by parts, okay? So let u equal to e to the power x and dv equal to cos x dx. So du is equal to e to the power x dx, and v is equal to integral of cos is negative sine. Derivative of sine is cos, no, just sine. Yeah, just sine x. That's it. Yeah. So your total integral is now negative e to the power x cos x plus what's u times v? Remember, we're doing this now. U times v is e to the power x sine x minus integral v du. So if you're going to take v and multiply by du, you're going to get e to the power x sine x dx. Now you see you're going in circles. You came back to the original question, but now what was this in the original question? What was e to the power x sine x in the original question? You came back to this question. It's like looped. E to the power x sine x, we call this I. Okay? We call that the integral. That's what we are evaluating. But now, in the I, I've got another I here. So you need to replace this entire thing with the I. Minus I. Obviously, you need to put a plus C here somewhere.
So it will be like 2i, yeah?
Yes.
If we go
Good.
to another
It's going to
side.
be 2I equals, let's take out e to the power x as a common factor here. So that becomes sine x minus cos x. And plus c, okay? So your final answer is I is equal to half e to the power x into sine x minus cos x plus another constant. Call it C1, and call it big constant. So that's your final answer. So the integral of this is actually this part here, and it was like a looped integral, okay? Yeah, it was kind of looped. Right, let's look at a problem like this. We want to find the integral of sine cube, but see what we want to evaluate. We want to evaluate this. All right, so how are we going to do this? We're going to say, okay, no need to get worried. You're just integrating this. Call this the integral. The integral is integral of sine n x dx. How are we going to integrate this? We can't really integrate that. So what we're going to do is we're going to break up the sine nx into y, because you can see your u dv, see how it is. That should be your u and that should be your v, uv, right? So it looks like yeah, you have to break up the n into n minus 1, looks like. So you're going to say integral of sine x times sine of n minus 1 x dx. Now, why did we do this? Because if you add the powers of sine x and sine n minus 1, remember sine 1 plus n minus 1, you get back to n, right? It's like breaking up sine cubed x into sine x times sine squared, okay? So something like this. So now, obviously, this is integral. This is in the form integral of u dv is equal to uv minus integral of v du. Now we need to choose our u and dv wisely. So I'm going to say let u equal to sine x. Let u equal to sine x? No. Let u equal to sine inverse x. Sorry, let u equal to sine x to the power n minus 1. Because if I differentiate this, then I will get n minus 2. So you should choose your u as this. This is your u, and that part is your dv, those two, okay? So let u equal to sine x to the power n minus 1 dx. No, there's no dx there. So what is du? What is the derivative of this? The derivative of this is n minus 1 sine x to the power n minus 2, and the derivative of the inside is cos x dx, okay? And what is your dv? Your dv is sine x dx. So I need to integrate this. V is equal to cos. Derivative of cos is sine. No, negative cos x. That's it. Right, because if I differentiate negative cos x, then I get sine x. Now, so the integral is now equal to, let's put the integral together, and then you see that eventually we'll come to that. The integral is actually equals to uv, that times that minus those two, right?
Which I
uv
think you
will be,
forgot negative in the cosine. Because in du equals to the n minus 1, because the derivative of sine x isn't a negative cosine x.
no, the derivative of sine is cos. The derivative of cosine is negative sine. Okay,
Okay.
yeah, that's correct. So uv will be negative cos x sine x. I'm going to write it as n minus 1 as a power like this, right? Negative cos x sine n minus 1x minus v du. uv minus v du. Minus minus makes a plus. V is cos x. Okay, let's write it as how the formula is represented. So uv, there's your u here, right? And your v is negative cos x minus v du. V and du is this whole thing here. N minus 1 sine n minus 2 cos x dx. Okay, now I need to simplify this. If I simplify this, negative cos x sine n minus 1x plus, I want to take out all the coefficients outside, right? So I'm going to take out n minus 1 outside. Cos squared x. Cos times cos is cos squared x sine n minus 2 x dx. There's an x there, right? What is supposed to be sine n minus 2x sine n minus 2x dx, which means there is no cos squared here. How did they get to that part? Trying to get, okay. So which means here that I need to get rid of, I need the sine n minus 2x dx, the cos squared. Why do I have a cos squared here? I've got cos x sine n minus 1. Why am I dividing it by n? N minus 2x dx. Negative 1 over n. I've got cos x sine n minus 1. I don't want to change anything here. But how can I change this? Negative 1 over n cos x sine n minus 1. N minus 1 over n sine n minus 2. Why do I have sine of n minus 2 there? And there's no cos. Derivative of this is correct. Integrate sine x, negative cos x. Unless we need to change the, we need to change the cos squared into 1 minus sine squared, okay? I'm going to try that out. I'm going to change the cos squared into 1 minus sine squared x. Now I'm going to multiply this inside. Yeah, I keep on writing the same thing. I'll just copy and paste. Right. So I'm going to multiply this on the inside and see what we get. If I multiply this on the inside, I'm going to get 1 times sine n minus 2 is sine n minus 2x. And this times this is negative sine nx dx. No brackets there, because all I've done is I've just distributed this on the inside here and on the inside here by making cos squared as 1 minus sine squared. Now, what I want to do is I want to take the n minus 1, right? And distribute it with the different integrals, sine n minus 2x dx, and then plus n minus 2x dx plus, not a plus, minus n minus 1. Remember, I'm distributing this into the integral. Minus n minus 1 integral of sine nx dx. But now remember what we are evaluating, sine nx dx. What is sine nx dx? Sine nx dx is I. So again, you got like a looped integral inside here. It's just algebra here, okay? That's n minus 1 integral sine n minus 2x dx power. That's a power, right? Minus n minus 1 times I, okay? And I think that's where they're getting the O divided by n now. Remember, this n minus 1, this part here is minus ni plus I. This part over here is basically, this is minus ni plus I, okay? This is minus ni plus I. So the I and the I cancels out. The minus ni goes to the other side, becomes ni, negative cos x sine n minus 1x plus n minus 1 sine n minus 2x dx. Now you just divide everything by n. So the integral is now equal to 1 over n cos x sine n minus 1x plus n minus 1 over n integral sine. It's just algebra involved here. There's no difficult integration. But remember what we want to find. This is the integral of sine nx. So what's the integral of, remember this whole thing is the integral of sine nx dx. So this implies we want to find the integral of sine cubed x dx. So we're just going to apply the formula. That's 1 over 3. N is 3, right? Formula because we know what to do. Right? We can just apply the reduction formula. So that's 1 over 3 cos x n minus 1, which is sine squared x, because n is 3. Subtract 3 over 2 integral sine what? 3 minus 2, which is just 1. And problem solved, because now we can integrate this. That's 1 over 3 cos x sine squared x minus 3 over 2. What's the integral of sine? Negative cos, right? And that's my answer. Okay. And last problem. Find the integral of sec cubed x dx. how are we going to find the integral of sec cubed x? We're going to break it up into parts, right? So we're going to say this here is equal to integral of sec cubed x, sec x times sec squared x dx. Okay? That's how we break it up. Let u equal to, try to use by parts now. Let u equal to sec x. So dv is equal to sec squared x dx, right? So what's the derivative of u? Remember, we're using the formula uv, udv is equal to uv minus integral of v du. Okay, so v is now equal to, what's the integral of sec squared? Is it a pair? Sec tan. Yeah, you're going to get tan x, right? Because the derivative of tan is sec squared. Right?
Yeah, I think so, yeah. But
Yeah.
derivative
So,
of the sec is sec divided by 10, yeah?
no. The derivative of sec is sec tan. Remember the table sec tan? Cosec
Oh,
negative,
yeah,
cosec
yeah,
quad.
yeah,
Yeah,
yeah, yeah, yeah, right, yeah.
that's the one. We're integrating in pairs now. Right, so that's correct. What's the derivative of sec? The derivative of sec is sec tan dx. Remember what we are doing? We're multiplying it out like this and then subtracting. Yeah, so the integral is now equals to uv, which is sec x tan x, minus v du. Integral of v is tan x, and du is all this. But now we got tan squared here, okay? Correct. Now, what is tan squared? Tan squared is sec squared minus 1. It's an identity. Remember, we got tan squared. Tan squared is sec squared x minus 1, right? Or 1 minus tan squared is sec squared. You know where we prove this from? Sine squared plus cos squared is equal to 1. You can get it from there. So this is tan squared. I'm going to replace it with sec squared x minus 1. Which is tan squared, right? Times sec x dx. Looks like this integral is also looped. If I multiply the integral with this, you can get integral of sec cubed x dx. Minus makes a plus. Integral of sec x dx. Okay. So again, I got a looped integral here. That's I. So that I will go across. It becomes 2I. Now you still got a problem with integral of sec x. Now, what is the integral of sec x dx? There's a trick to this, right? Right, so I'm not done with this integral. because I need to find what's the integral of sec x dx. Integral of sec x dx is equal to integral of sec x times sec x plus tan x. You have to use a trick like this: sec x plus tan x, sec x plus tan x dx. Right, so the top now becomes integral of sec squared x. Okay, no need to do this. You just need to make u substitution at the bottom, all right? Let u equal to sec x tan x. Let u equal to sec x plus tan x. So what is du equals to? The derivative of sec x is sec x tan x plus the derivative of tan is sec squared x and then dx. Do we have that? Yes, we do. We have sec x times sec x, which is sec squared x. Remember, we can factor this out and make it look like the numerator. The derivative appears in the integral. So you can take out sec x as a common factor, and you're left with sec x plus tan x plus sec x, right? So you're getting the same thing as a numerator, okay? If you multiply those two out, you get sec tan plus sec squared. So this is just basically integral of 1 over u du. And what's the integral of 1 over u? Len absolute value u plus c. Len, what's u? U is sec x tan x. Right, so what's my final answer here now? Remember 2i, we had 2i, so I'm going to divide everything by 2 here now, okay? So I is now equal to, instead of dividing by 2, multiply by half. Half sec x tan x plus, we still need to take this integral, divide by 2 or multiply by half. So half len okay, plus c. If you take, call it c1 and half times c1 is just another constant. Right, so I hope you guys understood everything. Don't forget to leave comments if you don't understand anything.